Hello guys, welcome to DJI Geospatial Solutions training. Today we are going to talk about the photogrammetry background and basics. This is the course part 1. In this course we will talk about what is photogrammetry, the pinhole imaging, and how to calculate the actual position of objects through images, and how to collect qualified images through drones. So let's get started. First question, what is photogrammetry? So photogrammetry is the science of extracting 3D spatial information from images. The process involves taking overlapping images of an object and converting them into 3D or 2D digital models. But how will this process be implemented? So let me use a video to explain to you. As you can see, this is a photo taken by DJI Mavic 3 Enterprise, and actually in this photo it contains lots of information. So let's see what information it contains. It has building, road, vehicles, trees, ground, and coal pile. So, but what about other information? For example, the coal pile volume, the open space area, the average height of the trees, and there are how many cars, area of the house, and the road wise. How about this other information? Can we get all this information? If we want to get this, we need the photogrammetry. But how would this be done? So first, we select a region of interest and we set the overlap for taking photos. So the drone in the field, it will following our parameters and taking lots of photos. So after the photo has been taken, we import all these photos into DJI Terra and conduct the photogrammetry workflow. By using DJI Terra, we could get a 2D image. We can measure the coordinate, measure the area, measure a length, right? And we can also generate a 3D model. So in 3D model, it's more intuitive, and we can even do the volume calculation on the 3D model. So like the video has showed, we select a target, we can measure the volume information. So this is basically the process of photogrammetry. But to better understand of this science or this workflow, we should start from the very first beginning. So let's start with pinhole imaging. It is a process how to image with a camera. So for example, we place a candle in front of a shelter with a small hole. So on the back wall, an inverted image of the candle will be formed, and this process we called small pinhole imaging. So now that we already have the images taken by drones, but how can we restore the actual ground object from the images? So we need to reserve the process of the pinhole imaging. Okay, and we need to calculate the actual position of the objects through images. So once we have the image, we know the position of the object. For example, object A in the image, we know its position. But how do we know the actual position of A on the ground? So the actual position of A is actually on the extension line connecting the image. So the actual position of object A is on the extension line connecting the image and the pinhole, right? If there's another sensor also captures the object A, so then object A is also on the line connecting the image of the second sensor and the pinhole. So we will know the object A is at the intersection of these two lines. So let's see the video again. If we already know the point A in the image, so its actual ground position is at the line connecting the image and the pinhole. So and same with another sensor. So the point A will be at the intersection of these two lines. If we are aware of the position of the two images during shooting and know the angle between the two shooting direction and distance, so we can calculate the spatial position of the target relative to the image position. For example, let's see this picture below. So if we already know the image A and image B we know its position, so we can definitely know the length between A and B, right? And if we both know the angle, this angle alpha and this angle beta, so using the mathematics forward intersection, we can calculate the object P its position. So this is very simple. We using the forward intersection. And how to collect the qualified ground objects images through drones? There are 4 key points we need to pay attention to. So the first one is the images should have accurate geographic information, and the images should meet the precision requirements, and the image should have sufficient overlap. The images should have a good exposure and focus with minimum distortion. So let's go through these 4 points one by one. First, the images should have accurate geographic information. As we all know, drones are equipped with GPS devices to get their position through GNSS satellites. So approximately with a general accuracy of meters. But however, aerial surveys will require higher precision positions. How could this be improved? So the first one, we could use the GCP. We're placing the GCP on the ground and know its high precision positioning. So we can identify these points during later construction and inserting the actual geographic coordinates into the image. Using this way, we could improve the accuracy of the results. So the second way, we could use the RTK technology. The position accuracy of drones can be improved to centimeter level. But however, we ultimately need is the high precision positioning coordinates for the image. So we also need to convert the coordinates of the drone RTK antenna to the image, so which requires the time synchronization. So the time synchronization accuracy of DJI drones can reach to microsecond level, which ensures the precise coordinates at the moment when capturing the image. And by the way, the DJI aerial surveying level drones, for example, the Mavic 3E and the M350, M300 plus P1, they are all equipped with position conversion system and time synchronization. So during the operation, the drones can convert high precise positions obtained from RTK antenna to the image in real time. So this can also reduce and eliminate the deployment of GCP. Second one is image should meet the accuracy requirements. So an image is composed with pixels, and each pixel is the smallest unit of the image. Taking an image in the air is like a net covering the ground, and a single grid is the smallest unit of the measurement. So the size of the grid affects the measurement accuracy. We generally use GSD, which is ground simple distance for short, to represent the size of the grid, also known as ground image resolution. So for example, if the GSD is 5 cm and an object in the image occupies 2 pixels, so which means the object length is 10 centimeter. So GSD is also related to the camera pixel size, focus length, and the distance from the object. So there's a formula has shows the relationship between these factors. So the smaller the GSD grid, the higher the measurement accuracy will be. We can obtain data with different resolution as well as accuracy by adjusting GSD during flying. So under the premise of high precision positioning of the image, its absolute accuracy can reach about twice of the GSD. So usually it's 1 to 2 GSD horizontally and 2 to 3 GSD vertically. So for example, if you need data with an accuracy of 5 centimeters, you can set the GSD to around 2.5 centimeters. So the third one is the image should have sufficient overlap. But what is overlap? So actually overlap has two parts. So there's a side overlap and a forward overlap. So side overlap ratios refers to the overlap of images between 2 adjacent flying routes, just as the video shows. So there's one flying route and there's another flying route, so it's between the 2 adjacent flying routes. This is the side overlap. And the forward overlap ratios refers to the overlap of images before and after the same flying route. Let's see this video. So it's on the same flying route, just the relationship is before and after. So the default value is 70% side overlap and 80% forward overlap. So this is a relatively safe value. But the terrain undulation has a significant impact on the degree of overlap. So for example, the drone has using a fixed flying altitude. So at this point, so the overlap will be 60 degrees. But with the drone is flying and the terrain is rising up, so at the top of the mountain, so you can see the overlap has down to 20%. And if there are some tall buildings or other objects, it can even down to 0. So the higher the height, the lower the value of overlap. So the terrain follow is very important for us. What is terrain follow? So so the drone maintaining a constant altitude fly to the ground during operations based on the terrain data obtained. It can reducing the impact of terrain undulations on overlap radius and can also ensure the constancy in data collection accuracy. The overlap ratios can or could also be approximately reduced to improve the flying efficiency. The DJI Mavic 3 has an independent real-time terrain follow function, and other products such as M300, M350, you can download the public terrain files from the internet, or you could import the terrain files generated with the post-processing. And the image should have a good image effect. It's equally important to collect the clear images with normal exposure during flight. So aerosol drones may cause motion blur due to being filmed at a very high speed. So a higher shutter speed will be used during the shooting. So there's a comparison between the electronic shutter and the mechanical shutter. So we could see that the mechanical shutter, it can get a very sharp image during very high speed. So we definitely need the mechanical shutter. And but if you're using a DJI professional aero drones, so its automatic exposure program has been optimized for aero senses. So it can also be operated in a fully automatic exposure mode. Okay, thanks for listening. This is the end of the part 1. So hoping this will be helpful for you. Let's continue discussing this in part 2. Bye.